Welcome to Inkpot. In this video, we will study about the different shapes of a histogram. Often, a smooth curve can be approximated by joining the midpoints of each bar of the histogram. So, for example, we have this histogram given here. We can join the midpoints of the bar, each rectangular bar, and then we can get a smooth curve, approximate smooth curve, which looks like this. Histograms can be characterized by two features: the number of peaks and its symmetry. The peaks or the mode of a histogram indicates the most frequent or common value. So the peak is also called the mode and it indicates the most common value. So remember, the height is telling us the how frequent that value is, or how many times is the value occurring. So the peak, wherever the height is the maximum, tells us the most common value in that data set. In a histogram, there can be either one peak or two peaks or more than two peaks. So if in the case of one peak, it's called a unimodal histogram or unimodal data. Uni again means one. With two peaks, it is called a bimodal data. Bi means two, and with more than two peaks, it's called a multimodal data. So as we have drawn here, this can be called a multimodal data. When we have more than two groups in a sample, two or more than two groups in a sample, then we can get more than one peak in the histogram. So we can get a bimodal or multimodal data. For example, if we are taking the data on hemoglobin, right, and in our data we have both males and females. Now females tend to have lower hemoglobin, so we will get probably two peaks in the data, one indicating the highest value for males and the other indicating a lower value, because for females most of the values will be concentrated along this value. The histogram could be symmetric or skewed, that means stretched to one side. So skewed means if it is stretched to any particular side instead of being symmetric. Symmetry here means that both the left and the right hand side are mirror images of each other. So here we have drawn three histograms. If we draw a vertical line from the middle of the histogram, then we can see that the left and the right hand sides are mirror images. So this histogram is, or this data is symmetric. There is symmetry in the data. This one has a long right tail. So we have a longer tail on this side. We call this a positively skewed data. It is stretched to the right. The long tail indicates that there is a stretch to the right, and similarly we have a negatively skewed or a left tailed data here. We get a positively skewed data or a long right tail because probably in the data some large values are pulling the entire distribution to the right. Similarly, a negatively skewed sample indicates the opposite. That means there are some very small values that are pulling the entire distribution towards the left. Most of the observations are concentrated in this area, but a few small observations are pulling this curve towards the left. And in symmetric data, we have a symmetric distribution of data along each of these points.